So today we're going to be covering some technologies that MapR provides for what we call the as it happens business. Being able to bring data into the company real time, being able to process it real time, and being able to combine operational and analytics capabilities in the same system, in the same cluster. So we'll walk through what those technologies are, and we'll walk through some use cases that exploit that so we can show how they're used. I'm also going to be unveiling something that we just brought up at Strata in New York, so I'll be going over a new technology that we're just launching this week called OHI that brings JSON and document database inside of our MapRDB product, and thus is really the first engine inside of Hadoop for doing both operational and analytical on hierarchical data. So in terms of adoption, certainly what we're seeing today is a movement from sort of the explorers, the experimenters, towards those who are starting to move into production. MapR already has the largest number of production cases in the world today. We support a large number of systems that are reliant on our failover capability, on our disaster recovery, and now business continuous capability, on our real-time capabilities for delivering as it happens performance. And as we move on and we start to see where the market evolves, we're going to see a lot more of these customers. So a lot more customers are very focused on Hadoop as a platform and as a product. And we're seeing a lot more use cases now where the business actually depends on what Hadoop provides. So that decision support is no longer experimental. It's no longer simply data science coming back and providing sort of hints to the business about what it might do, but actually something the business will alter its course on. So it's a big change for the market. There's really two kinds of companies we tend to run into. The early adopter companies that we saw when MapR launched back in 2009 and going over the next few years were the companies that had already started with big data at the very beginning. And those companies are very different. They have readopted Hadoop into their companies. They've changed their strategies to work with Hadoop and big data. They've altered, for instance, when data is coming in, that they respond immediately to the results of the analytics on that data instead of waiting for batch reporting on it. So those companies have really brought that into their DNA. They've changed their companies to accommodate. But they don't represent more than a minority of businesses. The vast majority are trying to figure out today, how can I actually incorporate this into a business change process? How can I actually change my business, change the politics, change the organizational structure, and of course the technology to support something where decision support is based on these masses of unstructured data that companies generate all the time and of course also bring out from the outside world all the time. The as it happens business means that we respond as soon as something comes in. So as soon as we get a new piece of data, it's already altering how we recommend to the business what to do. And that doesn't come automatically. That comes after you put in a product that provides that, and you also, of course, build something on top of Hadoop that can respond in that way. So it's not an easy thing to do, but I'll go through some of the steps you need to do if you want to move in that direction. I'm sure you've all heard of the Internet of Things, or the Internet of Everything, as it's often being called now. This is a massive trend. Anything that's being manufactured today is probably sending something back. I literally sat down with a European manufacturer, you'll all know, yesterday, and basically every single device that's important to them inside the things that they manufacture, and these are vehicles, send stuff back all the time. And so that information is gold, because that means, for example, that instead of waiting until something breaks on the road, I can actually anticipate that, and I can do something predictive, and I can actually repair the part before it fails. And this can be done very reliably. There are very, very good mathematics, very good science behind these sort of predictive failure models. So this is something that lots of companies are looking at. Companies are looking at things like feedback, customer response directly from the devices they manufacture, being able to respond in terms of quality control when something breaks. There's all sorts of things that people are doing with the Internet of Things today. And a remarkable number of things are connected. I'll come to one customer in a moment. You'll be surprised what's connected. Samsung is that customer. So Samsung today isn't just connecting your Galaxy S5, S6, not just your Note, they're connecting fridges. They're connecting appliances. There's all sorts of things that they're connecting in and bringing that data back to be analyzed with Hadoop real time. And that provides them a lot of the things I just mentioned. So things like quality control, things like knowing what users are doing, and being able to predict. That's the key thing, is moving from batch reporting that was telling you how things were to where things are going. And that's the key change for business. I can't name this one, but large semiconductor. If you think about quality control and you think about what sort of companies would first move to look at data sources real time and determine what they can do with them, it's going to be a manufacturing company like these because it's very expensive to manufacture. So you want to know when something's going to go wrong. And that's why this company leapt on top of Hadoop from the early days. They basically looked at it and said, every time we have a chip that fails, and this of course translates into something called yield for a semiconductor company. They're always looking at yield percentage to know of all the silicon I put in, how many actually come out the other end correctly. That's very, very expensive when they lose chips. And so they're going to put a big effort into actually looking at the machines on the assembly line that manufacture the chips. All the lithography machines, all the wafer production machines, all of those are wired back and sending in data real time so they can go fix these things in advance. Machine zone. How many people have kids at home that play video games online? Should be hopefully everybody. I mean, everybody I know does. But with games today, of course, there's a lot of stuff that's happening real time. In-app purchases, scoreboarding, social between the different players, chat, all the different stuff that's going on, of course, between the actual game and home base. Wherever that video game manufacturer is located, there's a constant stream of information about what users are doing. Some of this is used for quality, like we talked about in the previous examples, where they'll update their software in accordance. But some of it is also to know what users are doing and be able to adjust in-app purchases automatically. Machine Zone's an interesting one. They really use MapR for that combined operational and analytical capability. All of that data flow from all of their users is going into MapRDB, which is our database that processes everything real time. It's the only one in the industry that does that. But at the same time, they can also analyze, so they can also do reporting on that data to do this sort of predictive analysis at the same time. If you were to do this with a separate NoSQL engine, you would have to have two different systems and then ETL between them. And the minute you do that ETL, you're losing time, a lot of time. And so you really want something where you can do it in situ. And MapRDB is really the only one that does that. Rubicon, these guys are kind of like the eBay of ads. They basically have an enormous auction site where people are constantly bidding and trading on space for ads and of course the ads themselves. And they really have the market wrapped up because they basically control the biggest exchange, and they also have separate businesses that are on the producer and the consumer side of that auction. So they understand everything end to end. It's extremely profitable business for them, but they have to keep up. So everything here, again, critical that it's real time. They run 90 billion ad auctions per day. And on top of that, they also reach 96% of the internet audience. So these guys have huge scale issues, huge performance challenges, and that's why they've gone to MapR, because again, we can process that stuff all real time. There's a lot more use cases we've written up. A lot of people talk use case, and of course all there is a slide, and people say, well, I want to know more, I want to have the detail. We've done that. So Ted Dunning, who's our chief data scientist and chief application architect at MapR, has written with Ellen Friedman, who also works for MapR, a book called Real World Hadoop. If you want a copy of it, come to the stand, we'll get your business card and we'll send you one. But this goes into a great deal of detail on each of these use cases, so you can actually get into implementation and see how these are done, look at the architecture, and so on. Leading edge companies are asking, how do we re-platform? What does our technology look like tomorrow to enable this? And what's the overall approach, right? What's the best practice on doing this stuff? There's a few things I'll talk about here. One is apps used to dictate data format. Right, so even 10 years ago, you were dependent on what the application was to determine what the format is. That's no longer true. In most companies today, we're dealing with a lot of data formats, and Hadoop is the thing that comes in and provides that flexibility to interpret all of those formats. And we'll come on to drill in a moment, and I'll talk about how Apache Drill is something that allows you to actually query the formats directly without having to ETL. Data silos. This is well known. You guys will all know this. Data silos are the enemy of big data. The minute you start to isolate pieces of data, you lose. Quality comes from more data, not better algorithms. And so you really need to find ways to combine data together to get the right result. ETL. ETL is very often your enemy. ETL can provide better performance at the other end. The problem is you got to do it. And ETL is very complex to do. It takes time. You often have to involve things like DBAs to do ETL. It's very fault prone. And so what we want to move towards is ingest and go. And again, I'll show you how we do that. Real-time requires big data and fast data. So yes, we want scale, but you've also got to be able to respond with very, very low latency. And this is not something that traditional open source Hadoop does very well. It tends to be very batch-oriented. Where MapR is optimized Hadoop, including the open source code and our own code, is really around reducing those latencies and providing things as it happens. That's really what MapR's advantage is. So we combine everything in one platform. That's one key difference. You're going to get one cluster that's going to do everything. That's very, very different from Apache. With Apache, you're going to have multiple clusters doing different things in a batch-oriented modality. This is a combined operation. Think of this almost like you're combining your enterprise data warehouse with Oracle together, but on big data. We've done a lot of work on MapRDB over the last 12 months. We've done things like, aside from basic performance improvements, we've also provided geography independence. You can have multiple different tables in different locales and synchronize them automatically, either synchronous or semi-synchronous updates to all those tables. If you understand Golden Gate from Oracle, it's a very similar principle. We use a gateway technology we devised to basically transport any changes that occur to the database to the other locations. I'm going to come on, let me skip this slide actually. Let me come on to Ojai in a moment. This is the thing we announced at Strata. And this is going to come under the agility category. So we've talked about performance, I think, sufficiently, but we haven't talked about agility. This comes to the data formats. You really need to be able to respond to any data format you've got in place. Data formats evolve. If you've ever actually connected to the Twitter fire hose and you've had a look at what's available from that, if you run a promotion campaign, you're using Twitter data, it's hierarchical data, and it's data that changes all the time. You need to be able to respond to the structure that's in there. This is very, very different from the world before of relational and fixed schema, where you could understand in advance exactly what the columns and types would be. It's simply not true in the age of JSON and hierarchical documents. Data formats evolve. Apache Drill is the first solution we launched for this. So Apache Drill is an open source project started up by MapR, but supported by over 150 different companies that develop for it. Apache Drill is a project that allows you to use SQL, it's ANSI SQL compliant, but to query semi-structured, multi-structured data in place. So that means if you are looking at the Twitter fire hose, you can literally run SQL queries directly on that. You don't need to ETL it, you don't need to touch it. You put the Twitter data in, you query, it's that simple. And so that whole time of having to ETL before your analyst can start to figure out what am I looking for, what's important, goes away. Why is that so critical? Because in the data exploration phase, it's a cycle, it keeps going around. Data scientist sits down and says, I'm not sure what's important, let's look at this. Oh no, that's not important, let's look at this. If you've got to ETL every single time, that's going to consume an enormous amount of time. It's going to slow down your time to results, right? Your time to answers, and you want to get rid of that. And that's why Drill's so powerful. You just go straight against the data. If you're not in JSON, if you're in XML, you've got some log structure, no problem. It's adaptable. You can actually set up the format in a pluggable instrument, and then you can go ahead and query that directly. So it's very, very supple. It'll work with whatever data source you've got. Ojai, so this is the thing we announced this week in New York. Ojai is our efforts to put hierarchical data now in MapRDB. So for those of you that aren't familiar with MapRDB, it's an HBase compliant database that MapR provides, very, very high performance, and more importantly, very low response time, very, very low latency, and very consistent performance. And it's the only database in Hadoop that can actually combine operational and analytical together. So what we've now added is you can put JSON directly into the database. So if you think about this, we've got Drill on top, understanding JSON. We've now got JSON directly in the database as well. And you can actually query directly on the subfields of the JSON. So if there's things in there like arrays, or hashes, or anything else that you want to query that's inside the JSON, you can directly go look at those things. You can update elements of the JSON directly inside. Anybody use Mongo? Great. Mongo is the most popular NoSQL engine out there today. That's why we put this capability in, because everybody wants to go to documents in JSON. That's where the power is. If you're running a website and you're doing NoSQL for a website, this is the way you're going to want to go. Now you can actually do that in Hadoop with no ETL from your database. You just do it directly inside of Hadoop. Now, you don't have to read this stuff. I know the fonts are really small. The important thing is not to read this. The important thing is simply to say, why do we use documents? Because different things require different attributes. If you're running an e-tail website, you're going to describe a shoe differently than you're going to describe a bicycle, than you're going to describe a shirt, than you're going to describe a car. They're all going to be different. They'll have different attributes. People want to look up things like, I want shoes that have orange laces. I want cars that have wing mirrors that look like this. So you want to put those attributes in, define them. Does that fit well in relational? No, it doesn't. You're going to have tons of null fields and columns. It doesn't make sense. Documents the way you want to go. Product catalog, one of the most obvious ones. You try to do that in schemaful or relational there on the left, you end up with a query like that. It's a mess. Relational has not been a good fit for websites for a long time, and that's why NoSQL is so dominant there and why JSON's so dominant. Better example, do it with JSON. Add features easily. You want to go to the website and add a feature. I want to start looking at my product catalog. I want to add elements to the product catalog so I can search by certain things for a certain type of product. You just put it in. Very easy. Done. With MapRDB, you can literally just add that element in place. With Mongo, you have to take the whole document out and replace it. It's a much slower process. Some advice for the journey. So let's bring it back to the original theme. So no matter what use case you start off with, at some point it's going to become important enough to the business that the business depends on it. And so you need to think about production grade from the beginning. If you started off with Apache, you're going to run into issues later. You better start off with the right thing at the beginning. As it happens, it's just as much about business change as it is technology. Hopefully you guys have heard of this, you're aware of this, some of you may have gone through the big data journey already, but things like political obstacles that prevent data from moving from one part of the company to another, not understanding how to architect it and have a separate team actually responsible for providing those analytics back to the business, not putting somebody in charge like a CDO who's actually going to bring the correct skill sets into the business and implement, those are all problems. Those all have to be solved organizationally, and so there's big changes there. Additionally, if the business is going to actually use those incoming data streams, the as it happens data streams, and respond instantly, the business has to change, right? So this is very, very different than backwards looking reporting that we were doing on BI, extremely different. This means literally you have a dashboard that is telling you what to do based on those incoming streams. Good enough won't be. Good enough is what we work with today with Apache. Good enough won't be good enough later. You're going to need resiliency. You're going to need low latency. You're going to need low response times. All of those things are things that the business is eventually going to need. Why not build them in today? MapR is the top-ranked Hadoop distribution, according to multiple different groups. Forrester included. Top-ranked NoSQL engine, that's MapRDB. And top-ranked SQL on Hadoop solution because of its compatibility with data warehouse. Apache Drill is the easiest one to integrate with any existing enterprise data warehouse you have today. We've also, finally, and I'm winding up here, we've coupled this as well with a $50 million investment back into the community to provide free training. We spend a lot of money on developing very, very high quality training. We have huge teams building this. We give this back. This is one of the ways that we contribute back to the community. Why do we do this? Because the biggest obstacle for us getting customers working with MapR and Hadoop is skill set. It remains the case today that Hadoop is still relatively complicated. And so if we can make that easier, it's good for us and good for everybody else. And that's why we do this. So if you're out there saying, oh, I want to start with Hadoop, but I don't know much about this. I don't understand NoSQL. I don't understand Drill. I don't understand any element of big data. We have trainings on those. We have videos. We have courseware. You can go get certified on these. So it's free. It's available today. Please come visit us at MapR booth 18. Any further questions, we would be happy to take over there. And again, if you want to get a copy of any of the materials, the books, the use cases, we can get all those for you. We look forward to seeing you. Thank you.
Thanks very much,
Thank
Rob.
you.
Thank you.